The East African Rift System holds massive deposits of the exact materials required for the global energy transition. We're talking about world-class veins of high-grade nickel, cobalt, and graphite. But looking at this chart, you see an immediate paradox. While the African continent contains roughly 30% of the world's critical mineral reserves, it captures less than 1% of the actual financial value generated from global clean energy technologies. The primary cause of this severe value loss is a logistical marathon. To get these resources to the global market, producers rely on a fragmented network of unpaved roads and aging, slow-moving meter-gauge railways. This surface-level congestion creates average port dwell times stretching up to 7 days. For exporters, this physical bottleneck drives freight costs 40% higher. Extracting raw ore and dragging it slowly across inadequate surface infrastructure acts as a leaky economic engine. It bleeds regional wealth outward, allowing foreign refiners and manufacturers to capture the actual profits. To stop this outflow, participating nations have formed the African Mineral Strategy Group, establishing a unified political front. Their new policy is an absolute halt on exporting raw, unrefined ore. Instead, they are mandating domestic value addition, meaning the minerals must be processed and refined inside the continent before they leave. This creates an immediate logistical challenge. Producers now need to rapidly move, refine, and secure massive volumes of high-purity battery components without exposing them to surface-level delays, contamination, or theft. Enforcing a closed-loop policy of this scale is physically impossible using 20th-century roads. The region requires a total infrastructure leapfrog. To bypass the geographical limits of the East African Rift entirely, the solution sits below the surface, utilizing the boring company's proof rock tunneling technology. This diagram illustrates the small diameter strategy. By reducing standard 28-foot tunnels to just 12 feet, excavated material drops by a factor of 4. Furthermore, proof rock machines simultaneously dig and install concrete liners without stopping, achieving 1.6 kilometers per week. Because these machines leave behind a precise, continuous concrete shell, the tunnels can be vacuum sealed, matching the structural requirements for magnetic levitation Hyperloop pods. Operating at near Mach speeds, this system collapses the 1,300-kilometer overland journey from the Kabanga mining plateau to the coast. What currently takes 7 days of grueling road travel is reduced to a 90-minute autonomous sprint. Shifting transit entirely to the subsoil creates a frictionless, digital scheduling environment that is entirely immune to border delays, severe weather, and regional traffic. These subterranean freight loops would plug directly into regional refining hubs utilizing advanced hydromet processing technology. Looking at this flowchart, raw ore feeds into hydromet processing, eliminating traditional high-emission smelting. Powered by renewables, this drops carbon output by 73%. Furthermore, excavated dirt is repurposed into building bricks, eliminating toxic waste rock piles. Fusing hydromet refining, renewable energy, and continuous tunneling creates an industrial engine with zero wasted materials and zero lost value. This bar chart demonstrates the value multiplier. Exporting raw copper ore yields roughly $900 per ton, but if that ore is processed locally into refined cathodes, the market value spikes up to 10 times higher. Tanzania is already proving this model. By strictly enforcing local mineral trading centers and mandating domestic beneficiation, their mining sector recently achieved a 10.1% contribution to their total GDP. A Hyperloop network accelerates this capture. It pushes highly valuable finished battery components instantly to maritime gateways like the Port of Dar es Salaam, ready for global export at premium pricing. Keeping the entire value chain inland transitions East African nations from easily exploited resource quarries into price-setting anchors of the global green economy. This system also phases out the dangerous, unregulated, and environmentally destructive surface extraction model that has dominated the region for decades. Replacing it requires highly technical labor markets. Operating this closed loop demands specialized subterranean engineers, hydromet facility managers, and formal mining cooperatives to manage the automated logistics. By stepping a century of slow surface infrastructure and building a closed-loop subterranean economy, the wealth buried in the East African Rift is finally trapped within the continent, establishing the foundation for generational prosperity.